Natural and technical EMF polarization, horizontal and vertical EMF polarization, circular EMF polarization, the unknown connection between EMF and water. Part 3. Let's talk about an important concept, the polarization of EMF waves. Wave orientation, or polarity, refers to the direction in which the electric field oscillates, horizontal, vertical, or somewhere in between. In unpolarized sunlight, there's no systematic clockwise or counterclockwise. Each individual wave has linear polarization in a random orientation without a specific direction. Regarding the polarity of natural sunlight, the electric fields of photons can oscillate in different directions, from horizontal to vertical and everything in between. This makes sunlight unpolarized in terms of its polarity or vibration direction. When sunlight reflects off surfaces like water or asphalt, it becomes partially polarized, causing glare. Polaroid glasses contain a special filter layer that only lets vertically oriented light pass through. This blocks the horizontally polarized light from reflections, reducing glare. Most technical applications are linearly polarized, either horizontally or vertically, and are aligned with the receiving antenna's horizontal or vertical wave orientation. However, there are also applications where the EMF wave rotates. The rotation direction of electromagnetic waves refers to the rotation of the electric field, either clockwise or counterclockwise, called circular polarization. This concept is significant in technical applications, such as certain Wi-Fi systems, satellite communications, radar, and 5G networks. Circular polarization has significant advantages, especially for long-distance communication. It ensures more reliable signal reception by reducing dependency on the antenna's orientation, making it less affected by the receiver's rotation. In the US and Europe, circularly polarized antennas are commonly used for high frequencies, such as millimeter waves between 24 and 39 gigahertz and above, to reduce interference and enhance signal quality. However, it remains unclear whether this technology might have unforeseen consequences. The electromagnetic EMF spectrum is a continuous range of waves that vary in frequency and wavelength. This spectrum includes everything from radio waves to gamma radiation. In this visualization, you can see the EMF spectrum as a wave that increases in frequency and wave density from right to left. The light spectrum, shown as a horizontal bar, displays the rainbow colors. This is just a small part of the full EMF spectrum. Light only covers a very narrow band compared to all other forms of electromagnetic radiation. Let's now explore some common applications of the EMF spectrum. The frequencies we use vary widely, from very low to extremely high wavelengths. Radioactive radiation falls in the gamma range, with frequencies above 10 exahertz. This radiation carries very intense energy. 1 exahertz is a 1 with 18 zeros. X-rays use radiation in the X-ray range, typically between 10 petahertz and 10 exahertz. 1 petahertz is a 1 with 15 zeros. UV tanning beds use radiation in the ultraviolet range, with frequencies of 750 terahertz and above. Lamps fall under visible light with frequencies around 500 terahertz and produce light in the colors we see in a rainbow. TV infrared remotes work in the infrared range, between 300 gigahertz and 400 terahertz, and emit invisible waves that are received by the TV sensor. Microwaves use frequencies ranging from 300 megahertz to 300 gigahertz to heat food in microwave ovens. Mobile phones communicate via radio frequency in the range of 900 megahertz to 3 gigahertz. TV monitors use visible light to display images and, like other household devices, operate on an electrical frequency of 50 hertz or 60 hertz, depending on the region. High voltage lines generate electric fields that fall in the extremely low frequency range, also between 50 hertz and 60 hertz, which corresponds to the power frequency of electricity. Over the past 70 years, the number of devices emitting electromagnetic fields, EMF, has increased dramatically with unknown long-term effects. Just as environmental pollution harms the climate, the rise of EMF-emitting devices can lead to electrosmog. a form of pollution. Some individuals are highly sensitive to this and even develop symptoms resembling an allergy. Professor Martin Pal has found that EMF can, in some cases, even cause tinnitus. This was part 3 of our series, The Unknown Connection Between EMF and Water. Curious to learn more? Visit our website for deeper insights and exclusive content. If you enjoyed this video, let us know in the comments. We'd love to hear your thoughts. Don't forget to hit that thumbs up button. It really helps the channel grow. And if you haven't already, subscribe and turn on the bell icon so you never miss any of our future content. Share this video with your friends and family. Thanks for watching.